Come to a new problem solving, and it says magnetic field doesn't work. That means magnetic forces don't work. A U-shaped frame, the problem statement, with equal sides made of thin wire is suspended freely from the articulated joint in a vertical magnetic field. Oh, magnetic field is vertical, and the magnetic field magnitude is B, so it's uniform too. What is the maximum angle of deflection of the frame if a constant current I flows through it? The mass of a unit length of the wire is rho. Mass per unit length of the wire is rho. So how can we solve it? It's a big frame, so I'm going to focus on the center of mass of the frame. And I know that the center of mass of the frame is at a distance 2L/3, because L, I assumed simply L as the length of each of them. So center of mass will be 2L/3 from the axis of revolution. That means from here to 2/3 of its length. I know you can calculate it as well. This length is going to be 2L/3, and here resides its center of mass. And magnetic forces act on each conductor, but I guess only the force applied to the horizontal conductor turns the frame. The other forces, the other magnetic forces, they try to deform it. So because you can say these two forces will be simply, since the current in both wires are flowing in opposite directions, so they will get, the forces acting on these two wires will get cancelled out, and only the force acting on this frame is going to work, but the magnetic forces doesn't work. So here is the problem, and I'm going to solve it, and I have solved it already, and so I have a picture for its solution, and I'm going to show it to you, and the picture is here. This is the picture, and I'm trying to enlarge it. So this is the picture at the screen now, bigger, and you can see this. So let's label the angle of deflection by an angle alpha. You can see here a center of mass. Its center of mass is moving in this manner, and this end, and magnetic force you can see here, that is ILB, IL cross B. L and B are perpendicular to each other, so IL cross B is fine. And in this endeavor, I can see that the center of mass has been raised by a length this much length, and this length is 2L/3 1 minus cos alpha. 2L/3 1 minus cos alpha. This has been raised, and horizontal displacement is simply L sine alpha, because its horizontal displacement is simply this is L. So this horizontal displacement caused by the magnetic forces is L sine alpha in this direction. And I know that, but I can say it in loose sense that the magnetic force IBL performs the work, that is IBL multiplied by L sine alpha, that goes IBL square sine alpha. You can say, but the magnetic forces doesn't work. Magnetic forces, they don't work. I will refer you to go through the book of John D. Griffith, 4th edition. Find out the section of magnetic forces and then look for the explanation exactly. This work is certainly not being done by magnetic forces, but the current supplying, the voltage supplying source. But this is always told like work done by magnetic forces in physics textbooks, so it's not a new thing to call. We know there are many misnomers, like electromotive force is not the force, but we call it. You can tell me that no, I call it simply EMF. That means the same thing, boy. But to make things sure, I'm not going to describe the whole article of John D. Griffith. You have to read by yourself. And I'm going to solve this problem, and this problem is getting solved like it is this work that is equal to change in potential energy of the frame. This work, that means work done by magnetic force in loose sense, and it is nothing but IBL square sine alpha. This is the work done by magnetic force in this case, and this is going to be converted into the potential energy of the frame. Height is here, so you need to write the whole length, that is the potential energy, the rise in potential energy. You can write like 2 rho L square G1 minus cos alpha, and this will be equal to the work done by magnetic force, and you can get your result because you can write here that and what was exactly asked in the problem? It was asked perhaps the maximum angle of deflection. We are looking for a value of alpha. So you can find the value of alpha now, and by solving this you will get sine alpha upon 1 minus cos alpha equal to 2 rho G by IB, and left hand side itself is cot alpha by 2, and that is equal to 2 rho G upon IB. So you can write alpha equals to tan inverse IB upon 2 rho G, and I got the problem solved. Thank you very much for watching.